Okay, this is Math Module 5, Lesson 10, and this is our learning objective today. It is, and I'll just read it, I will be able to use the area model and division to show the equivalence of two fractions, which is basically the same learning objective as we had yesterday, and some of the problems are pretty much the same as well. So let's go ahead and get started. So I'm on page 45 of our math workbook, and I'll read the directions. It says each rectangle represents one. Compose the shaded fraction into larger fractional units. In other words, take the smaller fractional units and make an equivalent fraction using larger fractional units. Express the equivalent fractions in a number sentence using division. The first one has been done for you. And I'll just take a look at the first one as the example. I'll notice that when I look at the smaller fractional units, 1, 2, 3, 4, 5, 6. Each of these is sixths. So I will go ahead and label my sixths. And then I can see that the shaded portion of that is actually 4/6. And then when I look at the larger area model and how that's divided up, I can see that my sixths, or the area model itself, can be divided into, looks like thirds. 1/3, 2/3, 3/3. So what I'm going to do is, I know that in terms of the whole area model, if this shaded part is 1/3, this other shade is another third. Together, this is 2/3, right? So we know that 4/6 should equal 2/3, right? And so our division sentence simply is 4/6 divided by something over something gives me 2/3. And we know that 4 divided by 2 is 2, and 6 divided by 2 is 2/3. So 4/6 divided by 2 over 2 is 2/3. That's exactly what they're showing right here. Okay, so I've kind of started the next problem. I went ahead and labeled my twelfths. I can tell that there's 12 little boxes, so these are twelfths. And I know that the shaded area represents 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9 twelfths. Okay, so I'm starting off with 9 twelfths, and I got to find an equivalent fraction that represents the shaded area. And I've drawn some vertical lines showing how the larger area model is divided into fourths. So this is actually 1/4, 1/4, 1/4, and 1/4. So again, the shaded area for the whole area model is 3/4, right? 1/4 plus 1/4 plus 1/4 is 3/4. So 9 twelfths is the same as 3/4. Okay. So now I just got to fill in my division. So I got to figure out 9 divided by something equals 3. Well, 9 divided by 3 equals 3. And then 12 divided by something gives me 4. Well, 12 divided by 3 is 4. So 9 twelfths divided by 3 over 3 is 3/4. Which actually makes sense because before I had twelfths, and then now I have fourths, which is the larger fractional unit, and I have 3 of those fourths shaded in. Okay, so let's try another one. Let's look at D. I'm going to count up my smaller fractional units. 1, 2, 3, 4, 5, 6, 7, 8. These are eighths. Each of these little boxes is 1/8. Okay, and all together I can see that I have 1, 2, 3, 4, 5, 6. 6/8 is my smaller fractional unit that's shaded. And again, I can kind of take a look at the whole area model, and I notice that if I draw vertical lines, I can see that this is divided into fourths. So this would be 1/4, 1/4, 1/4, and 1/4. And again, the shaded area total is 3/4. So I know that 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8, or 6/8, is the same as 3/4. Now I got to figure out my division sentence. I'm going to say 6/8 divided by something over something gives me 3/4. Well, let's see. 6 divided by something gives me 3. Well, 6 divided by 2 gives me 3. 8 divided by something gives me 4. Well, 8 divided by 2 gives me 4. So there's my division sentence. 6/8 divided by 2 over 2 gives me 3/4. Moving right along. These are exactly like problem 1, so I'm not going to do another example problem there. Let's go ahead and do one of these problems. It says in number 3, draw an area model to represent each number sentence below. So let's do A. It says 4/10 equals 2/5. So 4/10 equals 4 divided by 2 over 10 divided by 2 equals 2/5. Another way to say that, and this is the way I prefer, is what I've been teaching, is 4/10 divided by 2 over 2 equals 2/5. I don't think you need to repeat the fraction in there. It just kind of gets more confusing. So we got to show 4/10 divided by 2 over 2 equals 2/5. Okay, so I'm going to start with my 4/10. And to me, the easiest way to draw tenths is to draw fifths and then divide it in half. So I'm going to draw fifths, which is 4 lines. So 1, 2, 3, 4, 5, that's fifths. And if I double those by drawing 1 line, so I have 2 rows, each of these should be tenths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. So I could label these. Each of these is a tenth. 1/10. 10th, 10th, 1/10, 1/10, and finally 1/10. Okay, so there's my 10/10. I got to show 4/10. So there's different ways you can show this. I'm going to show one way. There's other ways to do it, but this is one way to do it. Let's do it this way. 1, 2, 3, 4. Okay. So that's showing 4/10. Now we got to show how that equals 2/5. Well, if I look at my larger lines again and my vertical lines, I can see that this is 1/5. This whole column, I'll call them columns, is another fifth. This is another fifth. This is another fifth. And this is another fifth, because 2/10 make 1/5, right? Okay, so here I can see that if I add these two columns together, that's 2/5. So 4/10 equals 2/5. Okay? Moving along, let's do an example problem for number 4. It says, use division to rename each fraction. Draw a model if that helps you. See if you can use the largest common factor. So we're going to draw back on our knowledge of what factors are. Let's go ahead and do the first one. So 4/8, and basically they're just asking us to come up with an equivalent fraction to 4/8. So let's go ahead and use division to find a equivalent fraction. So what is a number I can divide 4 and 8 into? Well, I can divide it by 2 over 2, and that gives me 2/4. 4 divided by 2 is 2. 8 divided by 2 is 4. Now, can I divide this any further? Sure, I can divide my 2/4 by 2. Whoops. Divide by 2 over 2. And that gives me 2 divided by 2 is 1, and 4 divided by 2 is 2. Okay, so 4/8 is the same as 2/4, which is the same as 1/2. I could shortcut it by knowing, or 4/8 divided by the largest common factor between the two of them is 4. So I could divide it by 4 over 4. 4 divided by 4 is 1. 8 divided by 4 is 2. So that's why it's easier just to go ahead and divide once using the largest common factor, because you'll get to the smallest fraction that way, right? So We call this reducing fractions, so this is the most reduced fraction of 4/8. But either way is fine. Let's go ahead and do 12/20. So 12/20. Now I'm going to divide it by something that divides both into 12 and 20. Let's see, I know 4 goes into 12 and 20. 5 doesn't. 6 goes, no, 6 doesn't go, it goes into 12 but not 20. Let's try 4 and see what happens. I know 4 goes into 12 and 20. 12 divided by 4 is 3, and 20 divided by 4 is 5. So 3/5. 12/20 is the same as 3/5. Now I can ask myself, can I divide this any more? And I can't think of any numbers that go into 3 and 5. So this is my most reduced fraction. So 12/20 equals 3/5. And that's it for lesson 10.